Welcome to another lesson of Math Magic with Jen. Today we're going to work on decimals and fractions and converting between the two. So let's go ahead and check it out. So we've looked in a previous video about decimals and place value, and tenths is where we're going to start today. So tenths, of course, is the place value that is one digit to the right of the decimal point. So here, although it's typical for people to say 0.7 for dictation purposes, technically we'd read this as 7/10. And the beautiful part is converting between decimals and fractions is basically, can you read it and then write it as a fraction? So if I read 7/10, I can write 7/10. And if I read 5/10, we can write 5/10. Now, I will say we don't want students to reduce 5/10 to a half. Right now, we want to leave it with a denominator of 10 and in a little bit a denominator of hundredths or 100, because we want to see that continuity between the decimal name and the fraction, what it looks like. Okay, so try not to write your answer or your fraction in lowest terms. Don't reduce it. Okay. Now you can see down here that we have some area models. So yes, area models are used to represent decimals. Here it looks more like a square. And I've got this flat unit here, which is 10 strips. So this whole thing equals one whole item. And we have each of these strips is a tenth. So there's 10 of them. So 10/10 equals one whole item. And as you can see here, to represent 7/10, you just have to shade 7 of them. Pretty simple. All right. Can you graph more than one? So if we had something that looked like 3 ones and 8/10. Okay. So you'll notice that to the side here, we have a little blank. So we could write this in decimal form, or we could also write it in mixed number form. We could also write it in improper fraction form, and I'll show you that one in just a second. So here we would want to shade 3 whole area models. And then, as you can see, we would just shade 8 of them. Now, typically, we would go ahead and shade from left to right. You could shade any 8 that we have here. It's just easier for teachers for grading purposes if you have them always shade left to right. So it's faster to see that they did, in fact, shade 8 of them. Okay. Now, I mentioned just a second ago about improper fractions. So if you think about it, we have 10/10. So this one is 10/10. I have another 10. I have another 10. And then I have 8. So that would also be the same thing as 38/10. I know that's strange to write that, but we might want them to practice improper fractions along with mixed numbers. So it just depends. Okay. Now, I will say one thing I do like about these area models is that they're a great way to visualize and answer word problems. So you can see down here, we have a word problem that says, Miguel and his family are on a 5-mile bike ride. They have already gone 3.8 miles. How much further do they have to go? Now, in 4th grade, when they are learning decimals and they start learning decimal arithmetic, okay, and it continues into 5th grade, yes, at some point they're going to learn to do this. Absolutely. Okay. And of course, you end up having to borrow, and we get that answer. Okay. But the beautiful part is that they can actually answer this now just with this picture. So if we didn't want to open up that giant topic of let's subtract and line up the decimal points and borrow, okay, so if we want to get them problem solving without going there yet, yes, we'll go there, but just not yet, you'll see that we have one whole unit and 2/10 left. So here is a way that they can solve this problem without actually doing arithmetic. Again, they will learn it. I'm not saying we're anti-arithmetic, but maybe we're just not ready to go there yet. All right. So don't get mad at me. They're going to learn it. I promise. Okay. All right. Now we've talked about tenths. Let's talk about hundredths. Okay. So, the easiest way to transition between decimal form and fraction form is to read the place value and write that as a fraction. So here we would read this as 13, and because that 3 falls in the hundredth spot, we'd read it 13 hundredths, which we'd write as 13 hundredths. And then here we'd read this 25. And again, because the 5 falls in the hundredth spot, we'd read it 25 hundredths, which is 25 hundredths. And of course, don't reduce. We don't want to reduce right now that fraction because we want the continuity, the fluency between the decimal name with the place value and the fraction form. Okay. As you can see, we have another area model here. It's been cut into 100. Okay, now the good news is these aren't difficult to do. The bad news is that it would be really tedious if you had your students actually draw these area models. Can you imagine the time suck that would happen from doing 10 strips just to cut into 100 and then shade? So I would definitely suggest having graph paper ready to go for these, some sort of handout or laminated page that has the tenths as well as the hundredths so they can practice. Okay. You'll also notice that here we've shaded 25. So here it's 1, 2, that's 20, and then they have these bottom 5 here. But technically they could have also done the top 5, but there you have 25 hundredths. Your students are going to find this really easy. I mean, fourth grade, we're talking about, 10-year-olds, sometimes 11. So, yeah, they're going to be like, this is easy. Okay. So let's talk about some other things you can introduce into the classroom, which may make it a little bit more exciting. So one of the classroom tools that you can do, so these are some that I just found on the internet. I do own some of these that I've played with myself. So these are decimal towers. I was going to call them fraction towers. So what they are is that they're kind of thick, almost like a Duplo, and it's kind of the equivalent of fraction tiles, but in 3 dimensions. And they do interlock. And you'll notice I'm mentioning fraction and decimal. So as you can see, they have both the whole number, the decimal form, they've got the fraction form as well as the decimal form. So it's that fluency of getting to know between the two what a half looks like. It's the same thing as 0.5. What does a third look like? It looks the same as a repeating 3. So again, just kind of getting them to get used to the two versions that we have. Now, I will say you can also get the circles that are like pie cut into pie slices that will be fractions on one side and decimals on the other. So if you like that idea of having a bit of both, of a combination of decimals and fractions in a tool, they also have those. We also have decimal discs. So these are usually either magnetic pieces or little, like, kind of laminated cardboard. You can buy a set. The benefit here is that if you ask students to tell you how much this is, I'll just stop there. They would know that we have 3 tenths and 100. So this would be the same thing as 31. So there's, oh, sorry, 31 hundredths or 3 tenths and 100ths. There's a lot of different things you can do with decimal discs. I'm just showing one little super fast version of it, but definitely hands-on. You can have students playing with that. These decimal cards, I believe I bought a set of these from Lakeshore Learning Materials, but I'm sure there are other uh, institutions, websites that sell other learning tools. They also are laminated cards where they have a picture on one side, on the other. They're practicing writing what the actual decimal is represented. So here we can see that they've shaded 22 little blocks. So here would be 22 hundredths. Okay, now I was looking on the internet because, of course, it's a glorious place at times. And I did see a use of base 10 block. Yes, the good old-fashioned base 10 blocks that you could use for decimals as well. The idea being that a giant flat would be the one whole unit. And the rods, instead of the rods being tens, you could use those as tenths. And instead of the little units blocks being one, you could use those as hundredths. So that's kind of a neat use of a tool that if you already have invested in, maybe you previously taught second grade or first grade, but now you're moving to fourth grade, you can still reuse those base 10 blocks and use them in this way. So again, if you had 10 rods, that would be 10 tenths, which would equal one whole flat. Just an idea. Okay, the last topic that we're going to do. How do you go from fractions to decimals? If you ask an adult, they'll say, use a calculator. They're not wrong, but what their calculator is doing is long division. Okay, so the trickiest part of the whole process of switching from fractions to decimals is the starting part, or at least this is what I think the trickiest part is the starting out part. Excuse me. So what we have is we have, let's say, for example, I wanted to write 1/4 in decimal form. What we want to do is we want to divide 1 by 4. Okay, that feels wrong. Students will rebel because they're like, you can't take 4 into 1. What are you talking about? The bigger number should be underneath. And the answer back to them is yes. The fact that we can't take 4 into 1 is what makes the answer a decimal, a fraction of a whole or part of a whole. And so we've got to figure this out. I learned a long time ago that it's nice to have just the phrase inside out. And how that phrase works is that you just say inside for the numerator, out, for the denominator. So inside, out. So the 1 goes inside the division house, the 4 goes outside. Okay. Now, we've already had that moment of 4 doesn't go into 1. We go, I know. You're going to add a decimal and 0. Okay. Now, even though we have that decimal there, what they want to imagine is 4 going into 10. So even though that decimal's in that problem, we want to ask them, well, think of that instead of as 1.0 as 10. How many times does 4 go into 10? And they're going to say, oh, it goes in 2 times. So you can see the answer right here. It goes in 2 times for 8. And I get a remainder now of 2. All right. When do we stop? Okay. You keep adding zeros and keep dividing until you either get it to end with a remainder of 0 or it repeats. So for this problem, when I add one more 0 and go, and I get the answer of 20, and 4 goes into 20 5 times, I then get 20 minus 20 is 0. When you get a 0 at the end, you're done. Or it has to repeat and you get caught in a cycle and you notice, wow, this is going to keep repeating 1 forever or keep repeating 3 forever. And once you see that it's going to keep repeating, then you can stop and we write it in a special form. Okay. So it's kind of hard to walk through this process with it already done for you. So for those who watch this and kind of got it, but we're kind of like, what? I'm still a little bit confused. We're going to do one from start to finish. Okay, in fact, we're going to do 2 from start to finish. So that way you get feeling good about remembering this process. Now, again, with a calculator, you would just hit 1 divided by 4 and hit equals, and this is what it's giving you. But technically what the algorithm is doing is this whole process. Okay. I did not mention, however, what to do with your answer other than the fact that we know that we're done dividing. So the rule is you want to bring that decimal straight up into your answer. So some teachers will do it straight up at the beginning. Others will do it at the end. As long as students are bringing that decimal straight up, it's up to you. Okay. Another option to be aware of, and here, I'm actually going to write it over here to the side. Hopefully this helps. When students start this process and they go, oh, 4 doesn't go into 1, technically, when they say that 4 doesn't go into 1, they can actually write a 0 there. And then they know they're now going to have this 4 goes into 10 2 times for 8. And so having that 0 there might help with the bookkeeping purposes of aligning everything. So you'll have to kind of read the room. Maybe you want to instill in your students to go ahead and say 0, put that 0 there for a placeholder. Maybe you're a little bit more lax and they don't need to write a 0. You get to decide and also see what your students are feeling. Okay. All right. So we're going to try 2 of these right now. Okay. So the first one is convert 3/8 into decimal form. So the first thing I'm going to tell my students is, let's say inside out to set up the division. Okay. So we've got our little division house. Inside is the 3, outside is the 8. Okay. Now we're going to say, how many times does 8 go into 3? And they're going to say, no, I can't do it. So that moment they say, no, they can't do it, there's a couple things. One is they're going to add a decimal and 0. The other thing is, maybe we want them to go ahead and write a 0 straight above the 3 to say that, no, it didn't work. That's the optional part if you want that 0 straight above. Okay. Now we're going to ask our students, how many times does 8 go into 30? So they're going to need to know their 8s. So 8 times 3 is 24. 8 times 4 is 32. So it looks like 24 is our closest. I subtract down and I get a 6. Okay. We're not done. We got add another 0 to keep this going. Okay. How many times does 8 go into 60? Think that 7 for 56 is going to be our closest. 60 minus 56 is 4. Add another 0. It goes into 40 exactly 5 times, and we are done almost. Okay. So, of course, we want our students to tell us what the answer is. So their answer is, we're going to move that decimal straight up. Again, you could do that at the beginning or at the end. But what we're going to get is that 3/8 is the same thing as, okay, now you could read this as 0.375, or technically what this is 375 thousandths. That 5 is falling in the thousandth spot. Now you might be panicking going, what the heck happened? Well, it turns out that we're done right here. 3/8 and 375 thousandths are equivalent fractions. So these two are representing the exact same amount of a fraction. So this part right here is extra. You didn't need to write this. This is just me kind of trying to link the whole thing together. All right. How about 5/12? Let's try this one. So again, what we're going to start it is the phrase inside out. So the 5 goes inside, the 12 goes on the outside, and 12 doesn't go into 5. We'll put a 0, and we're going to start the division party by drawing a decimal point and 0. Okay. You can imagine that this process will go a lot faster if your students are really good with their multiplication times table facts. So this is 4th grade. They should hopefully remember them, but probably leading up to this section, you probably want them practicing. So maybe we practice 1 a day, 2 a day, do a little quiz, whatever it is to get their brains going. But hopefully they know their 12s. So 12 goes into 50. 4 times for 48. Okay. And add a 0. 12 goes into 20 once for 12. 12 goes into 80. I think that 6 times 12 times 6. 72. So what's going to happen now, and some students are going to see it faster than others. So some students are going to go, oh, we're going to keep getting 6. Other students might have to go through this a few times before they realize that, yeah, this is going to keep going on and on and on forever. So what our final answer is 416, and then you put this bar just over the 6. So that bar is telling anybody who understands fraction or decimal notation that that 6 is going to repeat forever. If you were to put a bar over 2 numbers, so I'm not saying this is our answer, but if we had a bar over 2 numbers, technically what that's doing is repeating 2 numbers over and over again. Okay, so we just want that bar over the 6. Now, some of you may be used to stopping and rounding. We don't want our students to stop and round unless we tell them to stop and round. So at this point, we're going to just assume that we're either going to go until it ends or it repeats. Unless we want them to practice stop and rounding. To a certain place. If you're going to round, you'd have to tell them round to the nearest hundredth or round to the nearest thousandth, or whatever that is. We did it. We got to the end of decimals and fractions and how they relate to each other. So you may need to go back and practice this again. You may be good to go. But remember again, keep working hard, keep practicing, and stay positive about learning math. It'll help not only you, but your students do well and succeed. So until next time, have a wonderful day and good luck as you're practicing this stuff. Bye.